This visualization represents a massive data set, 2,500 independent Major League Baseball games that need to be distributed to thousands of potential attendees. Managing this volume within a monolithic interface like Google Calendar creates a logistical bottleneck. These clients are designed for personal scheduling, not enterprise-scale operations. Within these standard clients, event data remains trapped. It cannot be programmatically accessed or distributed to third-party marketing tools in a headless, automated fashion. To bypass these limitations, we deploy a custom headless RSVP calendar sending engine directly inside an AWS account. True programmatic scaling for bulk outbound marketing requires a server-level architecture that operates independently of the standard calendar UI. The deployment of this architecture is handled by an AWS CloudFormation template. As shown in this diagram, the CloudFormation template abstracts the backend complexity, automatically generating the necessary compute, storage, and API routing nodes across the AWS environment. We will now trace the path of our 2,500 MLB games as they move through this newly deployed infrastructure. Utilizing infrastructure as code converts complex manual server configuration into a deployable backend as a service. The intake process begins by forwarding the 2,500 events from the monolithic client to a specific domain address. The data packet moves from the calendar into an AWS Simple Email Service, or SES node, configured at crate@yourdomain.com. This address is a crate inbox, a dedicated domain email box used strictly for programmatic ingestion rather than human communication. This configuration isolates the calendar payloads, keeping ingestion separate from general web traffic or internal mail. Once the SES crate receives the events, it immediately hands the payload off to the internal processing engine. This step effectively transforms a standard email inbox into a scalable, headless API intake valve. On the diagram, the payload moves from the SES node into the central inbound processor. This processor acts as an automated ETL engine, responsible for extracting, transforming, and loading the event data. For our MLB games, the processor extracts the raw calendar formatting and prepares it for structured database storage. Inside the processor node, the data block fractures into granular units. This disassembly separates metadata, timing, and organizer details into individual searchable components. Storing events as monolithic files prevents rapid retrieval. Disassembly is required to make individual data points queryable. This process converts static files into the granular data points necessary for web-scale distribution. These color-coded data points flow out of the processor into two storage layers, DynamoDB and Amazon S3. DynamoDB manages state and metadata, while Amazon S3 handles static assets. Above these cylinders, the AWS API Gateway serves as the central node for all external data requests. AWS Lambda functions act as the connective tissue, providing bidirectional communication between storage and the gateway. Upon request, the Lambdas pull discrete data from DynamoDB and reassemble them into complete calendar event payloads. The reassembled payloads are then pushed out through the API gateway. Decoupling storage from the reassembly compute layer allows the system to handle massive concurrent requests without database locking. The API gateway branches into two output paths, one for the console UI and another for third-party integrations like MailChimp. The first path uses display APIs to populate the native calendar invite server console. Within the console, the organizer uses decorator tools to apply themes, like this blue styling, to auto-generate preview schedules for the 2,500 events. The second path uses embedded REST APIs to generate the scripts needed for external platforms. These APIs power call-to-action buttons for landing pages and email tools such as MailChimp. The API gateway serves as the single source of truth, feeding both the human-readable GUI and the machine-readable marketing scripts. The system tracks these interactions using a sticky UID, a unique identifier embedded into every outgoing invite. When an end user receives a schedule, their specific interaction is tied to this sticky UID. When the user clicks yes or maybe, a data packet containing the sticky UID and the response is generated at the edge of the network. This user action triggers a specific payload that routes back to the system. The packet enters the API gateway, which routes the update through a Lambda function, modifying the corresponding DynamoDB cell to reflect the new RSVP state. Every embedded calendar invite operates as a distributed, two-way telemetry sensor, reporting state changes directly back to the database. As the diagram shows, the update in DynamoDB is instantly reflected in the organizer's console UI. This provides the organizer with real-time per-UID RSVP analytics natively within their AWS environment. This completes the lifecycle of the 2500 MLB events. The data moved from raw ingestion through ETL disassembly and out to distributed API endpoints. This entire loop is deployed without manual server configuration using the initial CloudFormation template. By leveraging these AWS services, standard calendar forwards are converted into a self-contained, auto-scaling event distribution and tracking network.